Hey guys, these are some notes for 4.2, more graphing quadratics. Excuse me. The difference here is we're graphing these quadratics is there's two other formats. Now, what you have to understand about quadratics is they're really important to us, and there's certain information that we always want to seek out, certain information that we're always looking for. And these other two formats, while they're not as simple to look at algebraically, like the standard form, y equals ax squared plus bx plus c, it's really simple to look at for things like maybe I want to add two of them together, or I want to do some other type of basic algebra. That's really handy for that. However, it gives us very little information in terms of what the graph's doing. We can tell if it's going up or going down. We can tell, where certain things happen. But generally speaking, it's not giving you a lot of information up front. So in this assignment, we're going to scrap that. We want to go a different route. And there's two different types that can be created from this. Okay, this is actually pretty closely linked to your quarter project that you're going to be dealing with later on this quarter. And so in this, these two varieties, we have what's called Vertex Form, and we have what's called Intercept Form. Vertex Form will look like this, and it should look pretty familiar to you. Y equals a parentheses x minus h close parentheses squared plus k. This is vertex form. The reason we call it vertex form is from this format, we can find the vertex is at hk. Now, when we were graphing these last time, the vertex was one of the critical things you had to find for me. Well, right now, the vertex is basically given by the equation. So if your goal is to find the vertex, find the high point of an object being thrown through the air, or find the low point of something that's swinging, different things like that. We can do that just looking at the vertex form. The intercept form is focused on something very different, and it's written as y equals a times x minus p times x minus q, where the x-intercepts are at the points p and at q. What that means is if you take a parabola drawn like this, these points, in no particular order, it doesn't matter which one you're talking about, are P and Q. If you wanted to know, hey, where's it cross the x-axis? Which are going to become super critical points. We're going to spend a lot of time this year looking for those two spots, or 3 spots, or 4 spots as we get into polynomials. These would be like your break-even points. If you're talking about a business, it's when are you going to put your head above water? If you're swimming, you dive in the water, right? So you dive in the water and you're coming back out. Question is, when do you get back out of the water? If I'm throwing a football or kicking a football, question is, where's it going to land? Where's the ball going to make it to? People get paid millions of dollars to throw a football. If they're going to get paid that money to throw a football, or let's look at a basketball hoop. Will a basketball go through the basketball hoop, or is it going to miss? Excuse me. I'm going to grab a cough drop. These are questions that we ask all the time, and we want to know, how predictable is the result. So as we go through today's assignment, we're going to keep in mind that different information is going to be presented by different equations. The good news is, for the most part, we're still going to do the same approach. You can use your calculator to graph it and find the vertex and find me the 2 points on each side. But let's look at a real basic example of each of these. Y equals 2 times x plus 3 squared plus 5. The nice thing about this is the vertex is not something I have to go searching for. I know from before that if I switch the sign of the value with x to negative 3, and I keep this one the way it is at 5, I'm going to have my vertex. I'm good to go. I'm still going to have to go in, find some other points, but I know that at negative 3 and 5, I have my vertex, and my axis of symmetry goes right through that. I also know it's upward trending because the 2 is positive. Just got to figure out some points. Over here, maybe I have an equation like y equals -1 times x plus 3, x minus 2. Okay, here's the deal. I've always said, switch the sign of the thing with x. It's still true here. At -3 and at +2, -3, there's a dot. At +2, there's a dot. I don't have the vertex. I'm going to have to find the vertex. There's a couple of ways to do it. If you're using the calculator, just continue to use the calculator to find the vertex. If, however, you don't want to use the calculator, the x value of the vertex will be at the average of p and q. In other words, if you take p plus q and divide it by 2, somewhere between those two dots, right in the middle, should be the axis of symmetry and give you your vertex, your x value of your vertex. In this case, it would be -3 plus 2 all over 2. That's -1 over 2. So -1/2. That would be like right here. So somewhere on this dotted line, at 1/2, the vertex is going to occur. I don't know what the height is yet. I'm going to have to plug that in. Again, this is why the calculator is going to help us just find the vertex and be done. But this is essentially what you're going to be doing. Still graphing, still giving me the vertex, axis of symmetry, and 2 points on each side of the vertex. But otherwise, it's the same type of assignment, just different information presented in a different way. All right, good luck, and we'll see you in class.